Okay, this is part 2 of our review for our mechanical quiz on chapter 2. We talked about I yesterday, and what we know about I is that I squared equals -1. So if it's a plain old I, I'm just going to treat it like a variable. But if it turns into I squared, I'm turning that into -1. So I cannot combine -2 minus 6i any more than I can combine -2 minus 6x. So I'm going to FOIL. And I get -14 minus times minus plus 2 times 5, 10i, minus times plus minus 6 times 7, 42 with an I. Notice how I'm doing that. Minus times minus before I worry about the 6 times 5. Minus times plus before I worry about the 2 times 7. So last times last, minus times minus plus, 6 times 5, 30, I times I squared. And that should be like a big flashing light to us right there. Plus 30i squared is plus 30 times -1, right? So this is, I'm going to do a little cleaning up. Minus 14, I've got a plus versus a minus number of i's, so they fight. Reduced to 32 i's, and the minuses win. And this is -1 times 30, or minus 30. So my final answer, minus 14 mixed with minus 30, is a total of minus 44 and a minus 32i. We like to put the real part first, the imaginary part second. Remember now, you can check those on your calculator. And I'll let you have your calculator with you, but you cannot just do them on your calculator and not show the process. Okay? So, we're just going to treat this I like it's an X. No big deal. If this was an X, no doubt what I'd do is distribute plus times minus minus 7 times 8, 56. Plus times minus minus 7 times 6, 42i. Plus times minus minus 8 times 7, 56. And plus times plus plus 8 times 4, 32i. I didn't get any I squareds, so that I might as well have been an X. It's just a variable now. I've got minus 56 mixed with minus 56, a whole bunch of minuses, 112. Minus 42 fighting against plus 32, minuses win that fight by 10. Nothing to it. Okay. Pretty simple, really, I think, compared to some of the others we have. Okay. If I've got a number times a number times a number, like 2 times 3 times 4, does it matter what order I multiply those in? Any order. So you might want to distribute this first, because you notice we're going to get I squareds. But I'm just going to multiply these first. Minus times minus plus, 8 times 4, 32i, to be distributed to this. Plus times minus minus, 32 times 5 is 30 times 5, 150, and 2 times 5, 10. 150 and 10, 160, with an I. 32 times 7, can we do that one in our head? It's 210, we see where that comes from, plus 14. 210 plus 14, 224. It's minus 224 I squared. There's our I squared. A lot of times I say flashing red light, but I'm going to say flashing blue light. I squared is -1, so we end up with positive 224 minus 160i. And yes, I would prefer it in that order. We want the i's, the real part first, imaginary part second. Any questions through that scenario, through that set of problems, 48 through 52? I think as far as what we were doing on the problem, the warm-up problem for today, a little bit easier. Okay. This is about like having negative 2x minus 3y plus 2z minus r. I can't combine any of these things. I've got negative 2 apples minus 3 oranges. I don't have the same units. It's just like having x here, y there. But I might be able to jailbreak some of these radicals and reduce things. For instance, 18 in this radical. I can take 2 into it, my smallest prime, I get 9, and I can take 3 into that and get 3. So that little hockey stick has a pair of 3s, which means a 3 can come out. So this is -2 times the 3 that pulls out times the square root of 2 that's stuck. Good there? Now, I have no problem if you don't do the tower here, the factor tower. If you look at 24 and you say, you know what, 4 goes into there 6 times, I can pull a 2 out. Square root of 4 is 2. That's fine. But I'm going to go through that. 24, smallest prime, 2 goes in there, 12, smallest prime, 2 goes in there, 6, smallest prime, 2 goes in there, 3. So I can pull a 2 out, -3 joined by the 2. What's left? 2 times 3, 6. Can I jailbreak anybody from this 6? It's just 2 times 3, so plus 2 root 6 minus, can I jailbreak anybody from the 8? It's 2 times 2 times 2, or 4 times 2. Square root of 4, 2, leaving a root 2. So when I had -2x minus 3y plus 2z minus r, I don't anymore. I now have like terms. Let's combine these. -2 times 3, -6 root 2 minus 6 root 6 plus 2 root 6 minus 2 root 2. I now have like terms. -6 apples, -2 apples, -8 apples. -6 apples, or oranges, plus 2 oranges, minuses win by 4. Is that all right? We did some of those on Chapter 1 mechanical test. But it's, again, it becomes emphasized in this chapter. Okay, give you a little head start on 56. Try it on your own, same process. If you need to look up here, you're certainly welcome to. If the factor pyramids are helpful to you, use them. But don't flatter me by using them. Here's how I would do this. 45, I recognize that's 9 times 5. And why is that better than 3 times 15? Because 9 is a perfect square. So I'm just looking to perfect squares divided. So 9 comes out as a 3. 9 comes out as a 3, leaves 5 behind. Can't do anything with this one. 20, sure, 2 times 10, 4 times 5, 1 times 20, but 4 times 5, 4 is a perfect square. 2 root 5. I think you guys are okay there, right? I need feedback. Nod, no dog cheese. All right. Okay, so I've got -6 root 5s and -3 root 5s. I'm going to put this one over here. -2 root 5s and a plain old minus root 3. So I'm going to have a plain old minus root 3. Nobody combines with them. But minuses mixed with minuses mixed with minuses, they all get along. I'm just adding them up and I end up with a bunch of minuses or negatives. 6 and 3, 9 and 2, 11. Do I have -11 root 15s or do I have -11 root 5s? Root 5s. I don't have any root 15s. Right? I don't combine those. How many of you beat me to that answer? Okay, so we're going to be good on this part tomorrow. All right, now, when we get to these, and these cause some problems, I had mentioned that there's, what we want to do when we have fractions with radicals, we want to reduce, we want to make the number smaller. And there's 3 ways to do it. Excuse me. We can jailbreak. That wouldn't probably be my first choice. We can reduce as fractions. For instance, 8 and 9 don't reduce, but 2 and 32, I can reduce those because they're both inside radicals. 2 and 2, I can reduce those because they're both outside the radical. 12 and 64, I can reduce those because they're both inside the radical. Reduce as fractions. Jailbreak. Well, I know I can jailbreak this 8. I can get a 4 out of there. And what I refer to as the V8 moment where you thump yourself in the head. Oh man, I started jailbreaking 9 and it's just 3. It's just a perfect square already. So maybe the first thing I would do would be square root of 8 on 3. And that's a good answer. But you're not getting full credit for that. Because 8 jailbreaks. This is 4 times 2. And square root of 4 is 2. 2 root 2 on 3. And then we double check. Can I reduce anything? 2 and 3? No. This 2 and 3, this 3, no times 2, because I got a radical and not radical, and 2 and 3 don't reduce anyway. Okay. All right. 59. Reduce first. Reduce as fractions. This 3 is stuck, but square root of 2 on square root of 32 reduces to 1 on 32. So you could 1 on 16. Thank you. You could reduce this to square root of 1 on square root of 16, but the square root of 1 is 1. Okay? Now, I suspect, I might be wrong, but I suspect if we took this, just because I've had honors pre-calculus students do this before, they then would multiply by root 16 on root 16. Not if I can make the numbers smaller. That's the V8 moment right there. I would jailbreak this, but in the process of jailbreaking 16, I would realize, oh man, square root of 16, that's 4. Just 3/4. Check and see, can we reduce the numbers? No. Good there? Okay. I can reduce the 2's as fractions. And 12 and 64, for sure, the biggest number that divides into them. 4 does. So this could become square root of 3. The 2's cancel. Square root of 3 reduced by 4 on square root of 16. 3 and 16 no longer reduce. Multiply by root 16 on root 16. You could. Then you'd get root 48. You'd have to jailbreak root 48 and reduce it again. Make them smaller every chance you get. That's the V8 moment. Root 3 on 4 again. Could have found the perfect square of 64 first. And then we reduced the 2, and now we got root 12 on 8. And then we jailbreak root 12, right? We make it 2 root 3, and then reduce the 2 and the 8, and we're right there. Okay? Could do that first, too. Okay? I'm just in the habit of always reducing by fractions. Okay? This 4 is not going to reduce by fractions. 6 can't reduce it, but 6 could reduce 75. Yes? By 3. So this is square root of 2 on 4 root 25. The 4 is stuck. That 4 is going to live on in the denominator. But the root 25 could be jailbreaked, but then we say, oh, there once again is a V8 moment. So this is root 2 on 4 times 5, or root 2, just plain old root 2 on 20. And this is where the dark side grabs your heart and says, oh, I can do one more thing. I can reduce his fractions. Let's get all the way to the answer and then blow it. We can't reduce this 2 with this 20. It's a root and not a root. All good there? Okay. 66. I would break any of these down first, maybe if I could. Maybe I'd do any jailbreaking, but there is no jailbreaking. So this is negative 4 root 5 times root 5. But what is root 5 times root 5? 5. You could do this in one step, but I'm just going to say this is negative 4 either times root 25 or just times 5. Before 4 root 5 times root 3, minus times plus. Geez, I hope you guys get in the habit of doing that. Minus times plus, minus. Because the most common error is to see a plus here. Now, 4 root 5 times root 3 is 4 root 5 times 3, or 15. Negative 20. Can root 15 jailbreak? It's just 3 times 5, so minus 4 root 15. Don't go to your calculators then and give me some decimal approximation. That's our final answer. Okay. Number 69. I'd reduce anything I could. Notice anything? We got that guy. Might as well just V8 that. Turn that into 2. So this is going to be, I might even do this. Just call it 2 here. Nothing else breaks down first. It just saves you bigger numbers later on if you'll do that. So now I got a FOIL. Plus times plus 2 root 3. Outsides. Plus times plus is a plus. I'm going to have 5 root 3 times root 2 root 6. Insides. Minus times plus minus. 2 times plain old 2, 4, but a root 2 along for the ride. And last times last, minus times plus minus, 2 times 5, 10, root 2 times root 2, 2. Okay? And now I'm going to combine anything I can. What can I combine? Just that multiplication, right? I've got an apple, an orange, and a pomegranate. Can't combine them. So I've got 2 root 3s plus 5 root 6s minus 4 root 2 minus 20. But make certain you look and see what you can combine there. All right, one more like that. 72. No jailbreaking here, right? There is something I could do if I was really clever, but let's say I wasn't clever here. And I just said, I'm going to FOIL this. I'm going to go through the foiling process. But what could I do if I was really clever? Yeah. Combine these and call it what? Yeah, call these 2 square root of 2's and just distribute that, right? But I'm going to go through the foiling process because sometimes we're going to have to FOIL it. If I call this 2 root 2, it's an apple plus an apple, 2 root 2's, and distribute that, that would work. But I'm going to FOIL negative 6 root 6, stop me if you need to, outsides, minus plus, minus 3 root 6, insides, minus 2 root 4, 2 times 2, lasts, minus 2 root 4 times 2. So I've got minus 6 root 6's. Where's my mistake? What's that? Minus 3 root 6. Wow. I'm going to stay with this video. Minus 3 root 6's and minus 3 root 6's gets me minus 6 root 6's. Oh, that's what I was doing. I was in the distributing mode. Minus 4, minus 4, minus 8. Is that okay? Thanks. Okay, after that, what do we have? We have your solutions. Please make certain as you're going through these, you guys are looking at your solutions. I can keep the video rolling here. Notice we got our I answers in there on some of these problems. We've got some possibilities of I's in our solution. Back here, we had the I's in solution somewhere here. There's our 27 with our I's in it. I'll keep this rolling if anybody has a question on one that they came across that caused problems. Okay, so we will take that. It'll be a much shortened version of this, but everything that's on here will be represented.